Particularly because glyphosate is so pervasive. It's considered to be so safe that people use it in their yards with their children playing there. They don't think it's a problem. It's all over the food supply. It's in the air. It's in the water. It's the most used herbicide on the planet in the United States, uses more per person than any other country in the world. And we have very high rates of autism. So it all kind of fit together. If you look at the rates of autism in first grade in the United States, versus in the public schools, versus the use of glyphosate over the previous 4 years. So that would be like the age of 2 to the age of 6 in the child's life. You take those two plots and you put them on the same page and they coincide. It's like a 0.99 correlation coefficient. It's absolutely stunning. And, people say, well, correlation doesn't mean causation. And then they say, well, how could, and of course, then we went on to find all kinds of other diseases. How could one chemical cause so many diseases? I refused to give up. I mean, I just felt like we were onto something really huge here, finding the biological mechanism. So it's been quite a journey. It's been a wonderful puzzle. And I feel like I've really kind of cracked the code with that book. And so I'm very pleased with what I've discovered, and including things like sleep disorder. I've seen, we have striking correlations. I've published papers where we show perfect correlation with sleep disorder, which is another thing that's really become rampant lately, and it wasn't really an issue back when I was young, And depression, anxiety, ADHD, autism, they're all going up dramatically in step with the rise in glyphosate usage.
If you just eat meat, then maybe that reduces some of your exposure. And then on top of that, even if you eat some of, let's say, the grain-fed cows, the fact that there was this one study that I saw that said, if you have sufficient, I think, aromatic amino acids, you may be able to block some of the antimicrobial effects of glyphosate. If we eat sufficient meat and then we do get exposed to some of the glyphosate, will we be protected because of those aromatic amino acids?
Well, I do think it's a good idea to eat a lot of foods that have aromatic amino acids to buffer them against the loss because of the glyphosate exposure, because as you know, the gut microbes produce aromatic amino acids for the host. Our cells are incompetent. They can't make those important molecules. And those are, part of the coding, the basic building blocks of proteins, but they're also precursors to an incredible number of important biologically active molecules. And I talk about that in my book. But so the pathway that makes aromatics is blocked by glyphosate. It's used in many microbes in our gut to make them for the host. Right. And the aromatics are precursors for serotonin, melatonin, dopamine, melanin, the skin tanning agent, epinephrine. So all of these really important hormones and the protection from the sun, all of those things come out of that chicken. Also thyroid hormones. So all of them come out of that shikimate pathway. All of them are going to be insufficient in the context of glyphosate chronically poisoning our gut microbes. Even, people are taking a lot of aminos as supplements these days, which I find interesting. You can get sort of a complex of aminos in general or specific amino acids. Glycine, of course, is a big one because that's the one that glyphosate is really messing up in the proteins. Of course, there's plenty of studies now that are showing that glyphosate is an endocrine disruptor. And that's kind of an interesting story because back when glyphosate was being studied by Monsanto, they did studies back in the 1970s on animal studies, and in vitro studies and things like that. And they made up some rules for those studies. And one thing they said was that if you test a chemical at a higher level of concentration and you don't find any evidence of toxicity, you don't need to test it at any lower level than that. That's kind of the lower limit. Everything lower is fine. That was an important rule. They said another rule was if you test an animal for 3 months, you expose it to glyphosate for 3 months, and you don't see any obvious problems, then that's fine. You don't have to look 4 months. Well, it turns out endocrine disruptors have this famous property that they're much toxic at very low levels than they are at higher levels. Seralini's group in France, where they exposed rats to low doses of glyphosate for their entire lifespan. And they monitored them all. So they went way beyond the 3 months. Okay. And then it was low dose. It was way below the minimum that they thought was problematic. It was actually below regulatory limits. So very reasonable, expected, environmental situations with this exposure. And by 3 months, the rats all looked fine. You really couldn't tell the difference between the exposed ones and the unexposed ones. By 4 months, they started to show problems. And by the end of their lifespan, they had lots of problems. The females had massive mammary tumors. The males had obvious kidney and liver damage. Both genders had various issues with the reproductive system, and they had early death. So it was very clear it was causing problems, but it took a long time, right. And it was low dose. And so that was 2012. That paper got retracted because of pressure from the industry, and then it got republished. So it still exists as a legitimate publication in its republished form. And that opened eyes. And I think since then, and especially in the last few years, there have been many papers coming out showing glyphosate toxicity at very low levels. It's really been quite a watershed moment, because it's taken that. Before 2012, there were no studies that looked at glyphosate at low dose, because it was like, what's the point? We've already shown it's not toxic at high dose. So how is it going to be toxic at low dose? So that really changed the picture. So now we've got a lot of really exciting papers, and even showing when you expose a pregnant mouse or a pregnant rat, I think it was mice, to low dose glyphosate, such that there was no obvious damage to the pregnant mouse. There was no obvious damage to the offspring. Right. The offspring grew up and they had pups, and then they grew up and they had pups, and you started to see worse and worse situations with each generation, down to like the third generation. It was quite remarkable. Various problems that came up in the later generations only because of that exposure in the great-great-grandmother during pregnancy. So that's another thing that's become known, is that, and they know how to do these studies now. They know exactly which window, during the pregnancy to expose them, to catch that moment when it's going to really disrupt the germline, because the female embryo makes her own future generation eggs very early, before she even has a brain. It's quite interesting.
At the very end of farming, that the practices for these GMO products, they just sprayed at the end so that the crops will dry like a week faster, so that they can push it to market.
Yeah, so actually that's the non-GMO crops, which is really quite interesting, because people think, I'm buying GMO, I'm buying non-GMO, that's safe. That's what they're thinking, right?
Oh, wow.
As long as I look for that non-GMO label, I'm okay. That's not true. And in fact, the highest levels are showing up on non-GMO crops that are sprayed routinely right before harvest to kill them. So if it's GMO, it's got the protection, so you can't use it as in that way.
Wow. Okay.
But, it's an interesting point to make, that it's the non-GMO crops that are sometimes the most dangerous. And in fact, a friend of mine, Tony Mitra, has been harassing his government in Canada for many years to get them to test different foods for glyphosate. Our government doesn't bother to test because it's perfectly safe. We know it's in there. We don't care. That's their attitude. Sure. He got Canada to do a big study where they tested thousands of different food samples for glyphosate, including Canadian grown foods, as well as imports from the US, from Europe, from Mexico. And he published a book called Poison Foods of North America based on their findings. It was quite interesting, because they consistently found much higher levels of glyphosate in food sourced from Canada or the United States compared to Europe. And interestingly, Mexico came up pretty much aligned with Europe. And also they found the highest levels consistently in surprising family, which is the legumes, the chickpeas, the garbanzo beans, hummus, for example, extremely high levels of glyphosate. Those are sprayed right before harvest as a desiccant, as you said correctly. And the wheat is also in the oats and the barley. So you get a lot of glyphosate in oat-based cookies and cereals, so like Cheerios and oatmeal. And then, for example, honey, there's been several papers on honey finding glyphosate in almost all the honey that you can test. But there was a paper that did a lot of honey samples from various places, certainly across the Americas, and even maybe Europe too. I don't remember, but the ones in the United States clearly showed up as the highest, consistently the highest levels, even in the organic honeys. When we use oils for cooking, we use butter or organic lard. Those are our two favorite oils, which is interesting because both of them, of course, have cholesterol, which is what people are always trying to avoid by switching over to vegetable oils. I think the vegetable oils are definitely inferior, even in the absence of glyphosate considerations. But the seed oils many of them are sprayed with glyphosate right before harvest. So you've got the glyphosate in the vegetable oils. You're right, probably more so than you would have in the animal-based. Acetobacter is a very common microbe that shows up in fermented foods, and there are very few microbes that can metabolize glyphosate. It has a complicated CP bond that but Acetobacter they have an enzyme that can break that CP bond and therefore can turn glyphosate into a nutrient source. of both energy and phosphorus and nitrogen. So it becomes a food to them. But it also clears the glyphosate from your body. So I find that really interesting. And I picked up on that. And I've been advocating either sauerkraut or any kind of fermented foods, and apple cider vinegar in particular, because that's also got acetobacter. So
that's interesting.
The recommendation that I have to people is to eat fermented foods for the reason that those microbes could be breaking down. And there was another study that showed specifically a Parkinsonian-like symptom, another kind of worm that was exposed to glyphosate and got Parkinson's-like symptoms, which again is a sort of neurological damage of the substantia nigra in the brainstem nuclei. So I think the glyphosate, it's been shown in multiple studies that it causes glutamate excitotoxicity. Mm-hmm. And so that's that's actually very much connected to autism as well, glutamate excitotoxicity. It means that it increases the glutamate receptor activity, which causes glutamate uptake into the cell, which then causes this excitatory response that causes oxidative damage through various oxidizing agents that get expressed in response to that glutamate signal. And melatonin, I believe melatonin is crucial for supplying sulfate to the brain so that it can clear garbage during sleep. It's quite interesting that one of the really important things that sleep does is to allow your neurons to recycle their waste materials. And so they need sulfate to do that. And melatonin is produced in the pineal gland in response to sunlight. And then it's packaged up with a sulfate. Each melatonin molecule gets stuck onto a sulfate, and the two of them get sent out together into the cerebrospinal fluid at night while you sleep. And so the melatonin is actually delivering sulfate to the neurons, which it needs in order to digest, in order to break down the debris. It's quite interesting. And the autistic kids have a huge problem with sulfate, and I talked about that a lot in my book. I think the sulfate dysfunction, disruption of the sulfate system is the way I should say it, in the body is a major driver behind many of these neurodegenerative diseases and neurological diseases. Absolutely. And that's again been shown in studies, and that's been shown in studies with pregnant rats, where you expose the rat to glyphosate during pregnancy, and then you look at the offspring and you can see that it's disrupted the thyroid system, the thyroid hormone in the offspring. Of course, this thyroid hormone, it comes out of the shikimate pathway, so you're going to have a deficiency in the hormone right there. And thyroid deficiency in the mother is linked to a 4-fold increased risk of autism in the child. That's in humans. So if a mother has thyroid deficiency, she has a much greater increased risk of producing an autistic child.